Okay, now we're going to talk about equations of circles. So far we've been dealing with circles and they've just been on a blank sheet of paper. Well, now we're going to talk about what does it look like if we put a circle on the grid, an XY coordinate plane. So I'm going to go back to what does a circle mean. Remember that a circle is anything that's the same distance away from the center. So if I have the center here, and all of these points are the same distance, that's the radius, right? So they all have that same distance of radius. So if we go back to distance, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so all we're going to do is, instead of calling that distance, we're going to give that distance a name, and that's radius. So we're saying, okay, radius is equal to the square root of instead of x2 minus x1, I'm going to say x is my variable minus h. And h is going to be a very specific number. And then we're also going to have y minus k, and k is also going to be a very specific number. H and K are exactly where that center is. So H and K are going to be the specific points where the center is located. So R is the radius and H and K is the center of our circle. Now all we're going to do is, we don't really want to write an equation with a square root in it, so all we did was square both sides. So this is really our standard equation of a circle. So you don't have to remember all that stuff that I just said. That's just why the equation is looking like this. So we have parentheses, x minus h squared plus y minus k squared equals r squared. It kind of looks like a squared plus b squared equals c squared. It's like the Pythagorean theorem. It's just we have some more going on with the a and the b. So also this might look familiar from when you did in Algebra 1, when you did transformations and quadratics, when you had hk as your vertex and absolute values. So keep that in mind too. Notice that this is x minus h and y minus k. So those will always be opposite of the coordinates that you see on the actual graph. So let's do some examples so we see how that turns out. So in this first example, we have a center of negative 5, 0. So this is my h and my k. And this is my radius that I'm going to be squaring. So in my formula, I have x minus negative 5. So minus negative 5 is plus. So that's what I mean by it will always be the opposite. And then I have y minus 0 squared. And I'm going to do 4.8 squared. Now, the book, and when we do some multiple choice answers and all that stuff, we typically won't leave it that way. So this is fine. X plus 5 quantity squared is fine. But y minus 0 is just y. So I'm going to write that as simply y squared. And we always want to square that radius to get just a number. So that's 23.04. So that would be my final answer for my equation of that circle. All right, let's do another one. So in this one, I have x minus 4 squared, that's my center, here's my h and k, plus y minus a negative 2, so that's going to be y plus 2 squared, and then I'm going to have my radius squared. So just to save us a step, 7 squared is equal to 49, so I'm just going to put right away that that's equal to 49. And then I just have to write that equation once. So there you go, there's my equation. Now in number 3, it's a little different, isn't it? They didn't give us a radius, they gave us the center, so this is my h and k. So let's go ahead and do that part. So I've got x minus 4 squared plus y plus 3 squared. Notice I changed that. And I don't have anything to plug in for r. And that's where this other point comes in. They gave us another point that is actually on the circle. So this is going to be plugged in for x and y. So 2 and 1 is going to be plugged in for x and y. And that'll help us solve for r. So I'm going to put 2 minus 4 squared plus 1 plus 3 squared. And that still equals r squared. So if we simplify that a little bit, 2 minus 4 is negative 2. And when I square that, that gives me 4. And then if I do 1 plus 3, that's 4, and 4 squared is 16. So I'm going to add those together, and I'm going to get 20 is r squared. Now notice I don't need to figure out what r is. In my equation, I need an r squared, don't I? So I'm just going to plug 20 into my r squared. So when I rewrite my equation, it's going to look like this. X minus 4 squared plus y plus 3 squared equals 20. And that's my final answer. So that one took a little bit more work, but not too bad. So let's do another one like that. All right, we're going to start off by writing our original equation. Here's our center, so this is my h and k. So I'm going to write x minus 3 squared plus y plus 1 squared equals r squared. Again, they didn't give me the r. I'm going to use this point as my x and y. I'm plugging that in for x and y. So 3 minus 3 squared plus 3 plus 1 squared equals r squared. So if I simplify 3 minus 3, that's just 0. And then here, 3 plus 1 is 4. And I square that, that's 16. So my r squared is just 16. So remember, I'm going to be plugging that in to my r squared here. So I'm replacing r squared with 16. I'm not squaring 16 again. I'm just writing x minus 3 squared plus y plus 1 squared equals, so I'm replacing that whole r squared with 16. And that's my final equation. All right, let's look at a graph. So what if we are given the equation, how would we graph that? Well, we're just going to work backwards. So I'm going to take my equation and find my hk. So this is my h and this is my k. So I'm going to do positive 3 and negative 1 is my hk. And this is the r squared. So if r squared is 4, how would I find just plain old r? Well, I'm just going to square root it, right? So r, plain old r, is going to be the square root of 4, which is 2. So if I graph that, I'm going to first graph my center, which is at 3, 1, 3, negative 1. That's right there. And then I'm going to count out a radius of 2 in all directions. So if I count up 2, that would be there. If I count to the left 2, that would be there. Down 2 would be there. And to the right 2 would be right there. And now I'm going to try to draw as best as I can. Don't make fun of my circle. I'm going to try to draw a circle as best I can through those 4 dots that I made. Remember, your circle will not go through the center, but you want to put the center on your graph so you know where that center is. Okay. So in this next example, they're asking us which one of these points is actually on this equation of the circle. So we're just going to be plugging in. So if I plug in point A, remember that's going to be my x and that's my y. So we'll see which one works out. So I'm going to plug in 5 in for the x. Then my equation says minus 13 plus, instead of y, I'm going to plug in 6. And then my equation says minus 6 squared equals 9. So we want to know, is this true? Does that work out? So if I do the 5 minus 13 squared, that's 64. 6 minus 6 is 0. So is that equal to 9? No, not at all. All right, next one. Let's try B. Maybe B will work. So I'm going to, that's my x and y. I'm going to use 14 minus 13 squared. Now I'm going to do 8 minus 6 squared and see if that equals 9. So if I do 14 minus 13 squared, that's 1. If I do 8 minus 6 squared, that's 4. So is that equal to 9? Nope. All right, try again. Let's try C. Maybe this is one of those trick questions where none of them work. All right, so again, C is 13 and 9, so I'm going to plug that in. So 13 minus 13 squared plus 9 minus 6 squared. We're going to see if that's equal to 9. So this is 0, and this is 9 minus 6 squared is 9. There we go. So that works, yes. So C is on the circle. All right. Our last example is giving us a different kind of thing that we have to solve for that says the center is h comma 1. So we don't know what the x coordinate of the center is. and they do give us the radius. So let's kind of write what that would look like as an equation. So we would have x minus, don't know, we'll just call that h, plus y minus 1 squared, and that's going to be equal to 3 squared. So in this first part, they're saying, well, we know a point, so we're going to be plugging that in to our equation. So if I plug that into the equation I have, that's going to give me 3 minus, remember I don't have h, so I'm just going to leave h there. And then I'm going to have negative 2 for the y, and then minus 1 squared, and equals 3 squared. Let's go ahead and put 9 instead of 3 squared. So let's simplify this as much as possible. I can't do anything with the 3 minus h squared, so I'm going to leave that there. Negative 2 minus 1 squared, that's going to give me 9. Okay, so that's nice, because if I subtract 9 from both sides, those will cancel. So I'm going to get, if I continue this over here, I have 3 minus h squared is equal to just 0. So if I want to get rid of the squared, all I have to do is square root both sides. So I'm going to be left with just 3 minus h. That's because the square and the square root cancel. Over here is just 0. So if I add the h over to the other side, h is equal to 3. So that one it was a little different than the ones we have been doing, but it's not too bad. We can still do all that. And now it says down here, what is the equation of this in standard form? So now that we know h, let's go ahead and plug that into our equation. So we're going to have x minus 3 quantity squared plus y minus 1 squared equals 9. And there you go. We will do the back of our note sheet in class, so hold on to that and make sure you have that in class.